Assalamualaikum, welcome folks to another video, which is the third one, and we're going to do application layer over here. So we did application layer in the last video, but here we're going to go in even more details. So it's actually the part of the course content I showed you in the first video. We're going to go through it very quickly, and we have 50 slides, so I'll try to make it as quick as possible because this is a theory thing. And it's not like 220 and 221 that you need to code it out, so explanations are low. If you have any questions, you can ask in the comments below. So the things you need to revise are the OSI model layers. So you have physical data link, network, transport, session, presentation, and application layer. Am I talking too fast today? I don't know why. Anyway, so we're going to work on the application layer. Let's for a little of review. Application, presentation, and session layers works with the software part, as you remember from the last video. So, and the three layers I mentioned just now is just application in TCP model. The protocols you will be using is DNS, HTTP, SSH, secure shell, which is new, you didn't do it before. FTP, file transfer protocol, you know that. TFTP, trivial file transfer protocol, SNMP, simple network management protocol, SMTP, simple main transfer protocol, and DHCP, dynamic host configuration protocol. Some are new, some are old. The things and the concepts that you need to know is we need to know application layer protocols and application software. For example, you have HTTP as protocol and you need Mozilla Firefox as your browser, or Safari, whatever. So let's go to the core things, and the part we'll be focusing a lot in this video is the protocols. So you have some main protocols that you need to absolutely remember. DNS, ARP, address resolution protocol. If you remember, I mentioned that this protocol deals with MAC address, the physical address, which is 48 bits long and very, very unique. And ICMP is the new protocol you need to know about. It's Internet Control Message Protocol. This is a replacement of POP. Depending on the situation, there could be use of TCP, UDP, Ethernet, PPP, and definitely uses Internet Protocol IP. So IP header, TCP header. TCP is the one that you will get, protocol address, port address. And HTTP header, application header, and the data itself will be there, of course. So the first thing we need to know is two methods of accessing information of devices. So there's client server and there's peer-to-peer. We'll learn about servers first. So the servers are repositories of information. So let me just give you a basic idea. For example, you have a disk like you see over here, and all the PCs, the clients, so-called clients, will download the files from this same disk. For example, web server, email server, Gmail servers, stuff like that. You share a Google Drive link and people download files from it. For example, I'm doing that too. So FTP server is a very similar, quite popular among us because we use it to download movies. I don't watch movies, I don't download it either. So, but people use it, So the FTP server comes in handy, and let's move on. It's nothing to explain over here. Okay, now this is an important issue. The main thing about the client server. For example, you have this device over here, and there's a network connection, and this device from this server you're downloading, you're uploading simultaneously, and you have many devices, so you can access them anytime. The biggest advantage of the model is that it is the centralization of the resources. So this device is the center of all resources. So usernames and passwords and files databases are easy to access. Pretty handy. However, there are disadvantages, and that's when P2P shows up. Peer-to-peer model, P2P networking, one peer to another. You can see it's strictly limited from one peer to another, and two or more computers connected via a network and can share resources. For example, printer is a good example. it doesn't have any server. Do you use a printer from a server? No, we don't. N devices can function as either a server or a client depending upon the required service. So the one who is receiving this could be a client. Okay, we'll describe P2P now. Before talking about the advantage, let's talk about one big disadvantage of P2P, because it decentralizes the services, which is absolute opposite of client. You have only one computer and you have the receiver is one computer, so accessing it is an issue, and it's really limited to and restricted to limited number of devices. All policies and usernames and passwords must be maintained on each peer device, so maintenance is a huge issue over here. And of course, if you have so many devices, maintaining security issue of all these devices is undoubtedly a challenge. However, the speed of data transfer is a big advantage, and depending on the number, the cost could become an advantage. And a peer-to-peer application, unlike a peer-to-peer network, allows a device to act as both client and server. For example, WhatsApp. So you need to just remember this connection. Okay, now as we know client and P2P, now you may ask, what is the disadvantage of class server? Servers will give you slow file uploading, downloading, and servers if hacked, there is a security issue, and of course it's an accessible issue. Servers can go down if it's overused. So these are some common server disadvantages. Now we'll learn about these servers. So DNS, we're going to learn about this DNS protocol, domain naming system. So what's a domain name? youtube.com, www.youtube.com. You know, this youtube.com is actually known as a domain name, which originally is the replacement of an IP address. So the actual youtube.com, the address you're supposed to write to reach youtube.com is some set of numbers like this over here: 198.133.219.25. If you write this, then you would access this website. But you cannot possibly remember these numbers, right? For example, you go to Google and you write Facebook. What if I tell you that there are some binary numbers you need to memorize for Facebook, Google, all the websites you know, each has a unique binary number, and you would go crazy. How can I remember that? So that's when this DNS comes to rescue us. It gives a domain name which is an easy, simple human name, understandable name, so that you can access the websites. That's the primary work of DNS. So as you can see over here, the IP address is replaced by a simple name as www.cisco.com. If you want to write it in the real address, it will be something like 200.20.20.1. Now it looks easy, but actually when you have many web addresses, you cannot possibly remember that. And even if you do, what's the point? Because you need to remember numbers every time you get a website. That's a big problem. So this is why domain naming system is necessary. And domain naming system, DNS, is an automatic client service. So it's a client service, and the programs require domain name lookup, send a resolution request to DNS resolver in the local operating system. So the DNS resolver is actually the one that look for the domain names. And if you have a domain name, you obviously need the domain naming system to handle and recognize the name, right? Because the computer knows the IP address. So you need DNS to make the name and also to check the name and to find the name. DNS and the browser. So first, the domain name of the URL is entered in the address field, and the browser passes the name to the resolver. Like I told you, you need the DNS too, because he's the one who gave you the name. So only he's the one who can recognize, oh, this is the actual name for these numbers address. So that DNS resolver will find the name, and then he will give you the address, which is a set of numbers. For example, 10.10.1.3. That's the one the computer recognizes, and that will be sent to the presentation layer or whatever. The further process will continue with that IP address, not the domain name, because domain name is for us to recognize, not for the. It's not a piece of. Sorry, it's not pleasant thing for the PC, you know, or the laptop or the mobile, whatever. So that's the idea. So the DNS resolver is a big role player over here. You need to remember him. And then, how does the resolver know where to send requests? Of course, there are IP addresses, subnet mask, default gateway, and the DNS server. You can see these things in your network options. If you go and just explore your network options, you will find this stuff. You know, IP address, subnet mask, default gateway, and you'll also be doing this in the lab. So I'm not gonna explain this much over here. But these are actually things you need to memorize and understand that these are some stuff that's not actually about explaining. It's some characteristics you need to know. Okay, moving to the next. Client said, like I told you, if you just go to the properties and you will find this stuff. Just see, I already told you. So we can check this out. It's very important and it's very interesting actually. Now you'll finally know the mystery. And though nobody uses Windows XP these days, the picture is of Windows XP. How pathetic. Okay. And if you have too much time in your hand, then you can go ahead and write command prompt and you can configure your own IP by writing ipconfig and do it for all, and you will get all your addresses, your DNS server, your gateway, your subnet mask, your IP address, everything will be provided. Try these things. Now, the MAC address. How does the resolver know to access the MAC address? Who works for MAC address again? ARP, I told you, right? So the ARP is the hero over here. With the help of ARP, you will know the MAC address. The ARP sends a request to know the MAC address, and then the address is verified. Once it's verified, the resolver has the MAC address and it can continue the process. So the DNS is using two layers. First it's detecting your IP and then it's detecting your MAC. So it's doing a lot of stuff within that, circling around in your browser. So look, realize, understand how much advanced and how speedy our internet has become nowadays. So what's this? Centralized DNS? No. What are the reasons? Single point of failure. Would you recommend a centralized DNS? Which means, would you recommend a client DNS? No. Single point of failure is a big option. Traffic volume, of course, like I told you, that if you have a server, a center, then everybody will have to use it. That's a big issue if the population is high, especially in a country like Bangladesh. That's a big no-no. Distance centralized database or database, whatever you call it, that's a, you understand just by reading the word. Maintenance is of course an issue. And if there's a traffic volume, you can't actually access it yourself. So that's a big issue. And once the maintenance is being done while people are accessing, there will be errors. And of course, there isn't a scale to get such a huge database. So what to do? The solution is to get a distributed database or database. How to do that? Look at this. For example, you have websites in Bangladesh, and let's go with the root BD. Pick one. So you have BD. Let's write it over here. You have drmc dot edu dot, it's not valid, but still let's use it, Dhaka or DHK dot science dot sec1. You see how it's being short from the root to the real subdomain. So this is how you distribute the database. Now things will become easier. Now organization works will have a different database, education works will have different database, top level network domains will have real database, and the .com, which is the rest of the stuff, will have a different database. So this is how you distribute it. I just showed you an example, no need to write it down. Now there are 13 root name servers worldwide contacted by local name server that cannot resolve name. So how many are there? 13. What are those? I don't know either, but just remember there are 13. Okay, nothing over here. Come on, move. If you don't understand what this figure is showing, it's actually a distribution of the database of the DNS. I think you'll understand just by looking at it, so I'm not going out of my way to explain this. Okay, from here to here to here to here to here. Just understand this. But if you still face problems, I told you, just let me know in the comments below. I think you guys are smart enough to understand this figure. And the DNS cache is where the DNS information is stored in the local memory, and we clear it up sometimes, right? So that's not new. The nslookup, you can use this in your CMD. This it will be actually used to query a domain name and get the IP address. It's pretty interesting. So if you use this, you will actually know the IP address of the domain name. That's interesting, huh? You'll do this in your lab. For example, if you have nslookup of that website, and then it will give you the actual address. So moving on to HTTP, Hypertext Transfer Protocol. We're almost at the end. HTTP, you already know this stuff. There's the client, which is the web browser, the server, the web server, the protocol HTTP or HTTPS, and the content, web documents, of course. That's something you can answer without seeing anything or knowing anything. So HTTP is a coding language, you also know that, and HTTP protocol works like the client server stuff. The HTTP server is the server, and of course you're the client, and logically speaking, you're actually at this moment you're the client in YouTube. And the web browser, there are some servers that are actually involved. For example, FTP, File Transfer Protocol, Telnet, SMTP, Simple Mail Transfer Protocol, and HTTP itself. Some languages that you need are HTML, JavaScript, and Java itself. So there are other languages, CSS, PHP. This is just examples. Okay, Apache Software Foundation. Maybe you're familiar with this because this is the core server which supports PHP, and if you have done PHP, you know this name. And there's nothing important here actually. URL. Okay, now URL is divided into 3 parts. This is important. So the first is actually the protocol, which we write HTTP, right? Then there's the host name, which is actually the domain name or the IP address. You can choose both. So Cisco is the host name. Port, we don't write port, but it actually exists. For example, 80. There's a port number that exists, but we don't write it, okay? But it doesn't mean it exists. It's not necessary, but it exists. You can write it and it will work. And of course the web server .html, for example .com, .tk, .net, .edu, whatever. And the subdomains, of course. So HTTP, how does it work? Before getting to HTTP, you need to use DNS, and the DNS does a lot of stuff. It goes and gets the IP address, the MAC address, it verifies, and then it allows the HTTP to start working. So you need DNS for this, okay? It's a lengthy process, and you'll do it in your lab. And this HTTP server this is server to server, and it's client server, so not P2P. And there's an issue of HTTP versions, and now we are actually in HTML5, but look at them talking about HTTP 1 and 1.1. So I'm talking about HTML5. So HTTP 1.0. HTTP 1.0 had get, post, head, and now as the days go by and 1.1 shows up, you have put and delete. The languages we use are HTML, CSS, JavaScript, PHP, Ruby on Rails. You know that, right? So the host name, you know that the web address, so-called web address, and before you need to address it like this. This is actually what the protocol is doing. This is the protocol message that you get. You don't get it, but this is how the protocol is working. So connection close, the date, the server that you used, the last modified the content length, content type, and data, of course. This is the work of the protocol. Okay, you don't say this because it's the work of the protocol, but it's better to know now. And I mixed up with HTTP and HTML today, right? Never mind. And here are some few sample codes of response. You see this, right? For at least you see this. None of you watching this video are not like this if you're not familiar with this. If you don't know what this is and you don't recognize it, you really need to consider like internet again. Okay, you need to really go out of your way to learn the internet, because 404 page not found is something everyone knows, especially. Now some other responses are 200. Okay, 301 moved permanently. You'll find that sometimes when your web address is actually moved to another address. You sometimes have 400 when downloading files. You see this error, that 400 bad request. So that's when the link is destroyed or the link is not working, something like that. And 505 is HTTP version error, which is very rare now. Okay, and they're almost in the end. And secure HTTP is HTTPS, that is secured, and that is the popular protocol that we are using nowadays instead of HTTP, but HTTP is still on action. So that's all for this video. Thank you for watching. Happy surviving, everyone. All you need to do is survive. And pardon my mixing up, I mess up a lot. Thank you.